There we go. So I'll give you a second to get caught up there. But yeah, it's a measure of central tendencies are your mean, your median, and your mode. Now, if you have a median, that's your middle value, and you have an even number, it's going to be in between these. So what do? You add them up, you divide them by 2, right? 5 plus 6 is equal 11. 11 divided by 2. Your median here would be 5.5. Right? Not that you can eyeball that, but what if they give you harder numbers? That's when it's useful to know how you actually do it. And then, of course, we just have the mode, which is the most common value. And you can have more than one. Again, if I'm looking at 10 people and I'm looking at their heights, if I have 2 people who are 6 feet and I have 2 people who are 5.5 feet, I have 2 modes there. And everyone else is a different height. Now, sometimes when we're dealing with data, though, sometimes if, again, I'm using people's height right now, right? Well, what if, Shaquille O'Neal is here? The dude's like 400 pounds and like 7 foot something. Yeah. He would be an outlier. We would not include him if we're looking at the average height because he skews the data too much. So it's a data point that can be ignored. It skews the data. So, if I have like a scatter plot diagram here, and you don't need to draw this, but, if I'm going like heights by age, you can see a general trend here that's like emerging, right? The older you get, the taller you get. That's a pretty fair conclusion. But, what if I have a baby who is just giant for some reason, right? This is an outlier. We would ignore that. Same thing if I have someone who maybe was born with dwarfism, so they're very short. We would probably ignore them in the general population when we look at the average height. So these outliers emerge in a couple different ways. Sometimes we looked at a trim mean, which is the average excluding the outliers. And again, trimmed mean sounds misleading. It's not just the average. Sometimes it's a trimmed median. Sometimes it's a trimmed mode. Usually it's the trimmed average, though. Usually it is a genuinely trimmed mean. Now, what is probably the most difficult thing of this entire unit for most people is the weighted mean. So how do most university classes work? How most university classes work is they're going to take 60% of your grade is on I'm going to type this. I'll just type this. So, how most university classes work is 60% of your grade is in class. And usually 40% is your final exam. All together, what's that add up to? It's going to add up to 100%. 100%, right? There we go. So what does this mean? Well, if I get, let's say I add up all my coursework, I get 40 grades out of the available 40 marks out of the available 60. So that's like a 66% on all my coursework. And then on the final exam, maybe I got a 52%. And it asks you, hey, what's the actual final grade? Well, we split this up into the parts. So I know that of the 60%, which as a decimal is 0.6, I got 40 out of 60 total marks, right? So I take how many marks did you get? How many marks were there an option of? What's the weight of it? And I add that into the other weighted categories. The other one is if I got a 52% on my final exam, well, what was the final exam out of? 100, right? And that's overall worth 40 marks. So all I'm doing now is I'm adding up these two components separately. And now I've accounted for 100% of that mark. Again, usually the weighted mean is what people struggle with the most. And you're probably not going to ask two things. They're probably going to ask you like calculate these four things and add them all together. They're going to give you more than two if you see this. And this can get more complex, of course, right? They might ask you, hey, if he got a 60% final grade, let's it's good. Let's actually just write that down here. So another example here of weighted mean might be if someone's final mark is 60% and he scored, I don't know, 75% on his coursework. What did he get on his final? So maybe you'll see a question like this. Now I'm just pulling this. I'm just kind of pulling this like out of thin air right now. So you have to give me a second here. I'll probably have to do some math, but so what is it asking here? It wants to know what your on your final exam. So in this case, I know 100% of the mark. I'll move this down. Is, oh, sorry, I forgot to add some weights here. Sorry. So, okay, I'm goofing this up a little bit. So if his finals mark is 60%, he scores 75% of his coursework, which is worth 70%. What did he get on his final exam, which is worth 30%? There we go. Sorry about that. Give you a second to get that written down. So in this case, what I know is that 100% of my grade is 70. Come on. 75 out of 100 times the total 0.7 plus something out of 0.3. In fact, not even 60%, it's 100%, it's 60%. So 60% of my grade came from these two things. More specifically, what this actually is just some type of an equation. 0.75 times 0.7. So I'm going to convert this into 0.6 because that's what that is.
Is that 75 out of 100 times 0.7? That actually equals 60%?
No, No, this itself is not equal 60%.
Oh, okay.
Yeah, this is equal to 0.525.
Oh, right.
Plus, in this case, it's 0.3. I'm going to say X, right? Because, you know, or yeah, I'm going to say X. This is an algebra question, technically. So what you'd have to do here is you'd have to eventually solve for X. I won't go through the full steps of that, but like that's what you'd have to do. You'd have to subtract the 0.525 from this, divide it by 0.3, and you would get what this number would be then. And there's other ways of doing it, but you know, I pushed algebra for a while. It's just it's a tried and true method. It should work for basically, well, everything. I'll give you a second just to get stuff written down. Well, there's no, well, why not? The other way here is, you know, if I know I got 60% and I know that my coursework's worth 52.5%, you know, that's going to be 7.5. So I got 7.5 marks out of a total of 30 marks in that case. So there's the other way in case you don't like algebra. If this makes sense.
Right, yeah.
Yeah. I know that's not very neat and orderly over here, but
I got it, though.
so two different ways. Either you need to use algebra or you can, or it's like, and again, like where I get the 7.5 from is that's what I have to get. I know my final mark. I know I had to have gotten that on my final, and I know it's out of a total 30 marks. So in that case, I can see, oh, I got 25% of my final exam, right? He bombed it. Okay, so the last part here was we looked at percentile. Percentile is the number, it's a number between 1 and 99 that shows what percentage of values in a data set are below the given value. For the key word here, below. You will be given a question, it will be multiple choice, and they will have this, and it will give you the values below and above. So the key thing you're going to need to know here is below. And if you're ever unsure, like, what does it mean? You know, Shaq, super tall basketball player, you know, he's in the 99th percentile for height, right? He's tall. He is taller than 99% of the population. He's taller than 99.999, you know, something like that. But we don't use that number usually.
This,
Oh,
there.
I'm just trying to think of another example, like for who's the Peter Dinklage? I'm spelling it wrong, but you know that's the dwarf from Game of Thrones, right? That's Tyrion Lannister. You know, he'd be in like I don't know, the third percentile for height. I'm just pulling a random number out there, right? He's short, so it's just giving you like the difference there between those two numbers, right? If you're in a high percentile, you're taller, you're smarter, you're richer than most of the population. If you're in a very low percentile, it means like everyone else is taller or richer than you, for example. So that's understanding it, but how do you calculate it? So how do you calculate percentile? Well, we use what's called the percentile rank. So this is the percentage of values that are lower than the given number. It's the same thing is really what up above is, but this is how we calculate, and we have a formula for this. We say that, hey, it's PR, percentile rank, is equal to the number of values below divided by n, which is how many values, right? So if I have 10 people and I've matched their height and I want to know like, hey, what's this guy? There's 7 people below him. It'd be 7. There's a total of 10 divided by 10. And we times that whole thing by 100. Right? So easy enough. The complicating factor here, though, is if there is a tied value, it's not used in the numerator. It's not used for the below, right? It's not below. If there's someone who is the same height as me, they're not shorter than me. I don't use them when I'm looking at below. I still count them as a person. They're still in the n part, but they're not counted as that number below. So that's statistics right there. The next unit we're going to do, and we'll end after this one today, is unit 4, probability and odds. So, probability and odds. So if we start here with something called experimental probability. If you can't see, let me know. But experimental probability is based on an experiment. It's based on a data set, something that actually happened. So maybe, if I'm rolling a dice, which are 6-sided, that's something you're going to need to know that because they're probably going to ask you about a 6-sided dice question. If they ask you, hey, what's the probability of rolling a 2? Here's a data set. Maybe they're giving you like, yeah, it was a 1, a 2, a 2, a 5, a 6, and a 6. Maybe this is your data set. Well, we always use the same formula, which is the probability of, in this case, probability of a 2, whatever happened is equal to it's the number of desirable outcomes divided by the total number of outcomes. Oh, okay. I'm not even going to fix the spelling. Oh. So in this case, if I'm asking, hey, what's the probability of me rolling a 2 using this data set? Well, there was 2 desirable outcomes, but there was a total of 6. So it's a 2 out of 6 or a 1 out of 3. There's a 1 in 3 chance. So that's experimental probability. Now, the other one, though, that we have theoretical probability. What should have happened? If I roll a dice 6 times, I should get a 1, 2, 3, 4, 5, 6, right? So that's the difference, is it's the expected odds. So one thing that might happen is, what's your odds of rolling a 2 1,000 times, for example? Well, you do, well, it's 1 out of 6. I have a 1 in 6 chance of fairly rolling a 2 times by 1,000. So the difference between experimental and theoretical is, well, did it happen or is it what you expect? And then we also look at something called sample size, which is the total amount of data being counted. And this can be influenced by a lot of things. They don't often ask that about, what's a flaw with this data set? It could come up, but it's very, very rare. And that's just like applying some common sense. So simple enough, probability. How is probability different from odds? So odds, we express the chance of something happening as a ratio. Whenever we're dealing with odds, we're looking at a ratio. They'll mean the same thing, which I'll get to in a second. So a ratio compares the number of desirable outcomes to the number of undesirable outcomes. But the key word there is ratio. So let's look at an example here to kind of really drive home that difference. I'll give you a second to get caught up there. So let's do an example here to drive this home. Let's imagine I play 4 hockey games. I win 3 and I lose 1. This is not a ratio. I'll put a comma there. I'll just do that. I win 3 and I lose 1. Now, the probability of me winning a game in this case is 3 out of 4, right? The odds of me, well, my desirable outcome is 3, and my undesirable outcome of this data set of 4 is 1. So this is the difference between those two. Probability is 3 over, this is 3 over 4, effectively a fraction. And then the odds are 3 to 1. So they're going to ask you probably, hey, what's the odds of this thing happening, or convert this odd to a probability? Well, you would know then that, oh, well, there's a total data set of 4 then based off that, because you have to add those 2 up. And finally, the only other thing here is you're going to be asked to or sorry, you might not be asked, but you're gonna need to know the differences between how they represent data. And there's a couple ways that this can happen. So how can you express the same thing? Hey, you win 3 games, you'll lose 1. Well, you can express it as a fraction. You can express that as a decimal. You can turn that into a percentage. You can do words, or you can do odds, which is a ratio. So you're just going to need to have that interchangeable knowledge. Is they might give you a word question, and you'll have to convert like there's 3 wins and 1 loss into odds, for example. So fraction 3 over 4, decimal 0.75. As a percentage, what's my odds of winning? Well, it looks like it's about 75%. As a words, it's 3 in 4. And then as odds, we establish it's 3 to 1. These all mean the exact same thing, right? This is all telling you the exact same information about that data. It's just how you use the language around it. Okay. So we're going to end it off there. Now, tomorrow we're going to be doing the reviews will be a little bit longer. I'm going to guess we're probably not going to finish till 1:30. But so we'll be a little bit longer. But the reason for that is just because we did that stuff more recently. That's why I'm dedicating more time to stuff from earlier in the course. Either way, like we have to do 3 units on one of the days. That's just reality. I'm choosing to do the latest 3 units, especially because they kind of all match together. So now it's just time to just work on your workbooks there. You can look at your ones you have. You can download the blank ones on the LMS and look at those. There's the textbook. It's just time to practice this. I recommend go to the chapter test. It's a really good resource there to kind of test your knowledge. But yeah, we're almost done. So yeah, if you have any questions, let me know.